Welcome back. Today we're going to be talking about the chain rule, and I'm going to be going over 5 multiple choice and 3 long answer related to the chain rule. Okay, so let's quickly review what does the chain rule say. The chain rule says that if we have a function y is equal to f of g of x, then the derivative of that function is equal to f prime of g of x times g prime of x. All right, so for each of these, I'm first going to identify what is our f and what is our g. Okay, so let's go ahead and do that. So for this one here, we have 3x squared minus 5 to the power of 4. And so I'm going to define, in this situation, ignore this f of x, right? Let's just consider this as y equals something. Okay, so our f of x, which being like the same as this one, would be x to the power of 4, because this whole thing is to the power of 4, so it's x to the power of 4. And then g of x, the function that's being raised to that power of 4 that's being applied here, is 3x squared minus 5. Okay, so now I'm going to be using this formula in order to find the answer. So in this case, our y prime is going to be equal to f prime of g of x. So I'm going to put the 4 in front and then multiply by, we're going to get 3x squared minus 5 to just repeat g of x, and then power of 3. And then for g prime of x, we need to take the derivative of just what's inside the brackets. So using power rule, the derivative of what's inside the brackets is 6x, so times 6x. And there we go. Now we could actually make this a little bit nicer and multiply those two, get 24x times 3x squared minus 5 to the power of 3. However, I noticed that the answer that matches what we did is letter C. So I'm just going to go ahead and circle C, and we'll move on to the next one. All right, so next I'm going to go ahead and find the derivative of this one as well. So this one is g of x is equal to sine of x cubed plus 2x. So for this one, let's let g of x here equal to y once again. And then we're going to have that if y is equal to f of g of x, then the derivative of y is going to equal to f prime of g of x times g prime of x, derivative g, right? So therefore, in this particular situation, notice that that f is going to be the outside function, so sine of x, and then g, the inner function, is going to be x cubed plus 2x. Okay, so therefore, what is the derivative of sine x? Well, derivative of sine x is cosine of x. And then what's the derivative of g of x? Well, using power rule, we're going to get that's 3x squared plus 2. And so therefore, the answer will be cosine of x cubed plus 2x times 3x squared plus 2, like that. And let's see if any of those matches. Well, if we just put this in front rather than it being at the back there, then this second one here, C, does indeed match what we've just done. And so that's going to be our answer for that one. All right, so now they're asking us which one of these is the correct derivative. Okay, so first thing I'm going to do is I'm actually going to switch the formatting of h of x and say h of x is equal to 5x minus 1 to the power of 1/2, because recall that square root is the same as power of 1/2. Now I'm going to use the chain rule in order to find the derivative for h of x. So I'm going to put 1/2 out in front, and then 5x minus 1, and then to the power of 1/2 minus 1, which is negative 1/2. And then for the times g of x part, we have to do times the derivative of 5x minus 1. And derivative of 5x minus 1 is 5. So I'll be multiplying that by 5. Okay, so what is that going to be equal to? If we neaten that up, we're going to get 5 over 2 times the square root of 5x minus 1, which is this one here. And actually notice, something else I notice actually though, is that if we keep it in this format, we also get b. So both b and c are correct. A is not quite correct because A forgot to like multiply by the 5, so it forgot to do the taking the derivative of the g of x part of the 5x minus 1. So both B and C are correct, which makes D the correct final answer. The next question asks, which of these require the chain rule for differentiation? So let's start with A. So A, I would say, does require the chain rule because it has composite functions, right? It has 2x plus 3 as one function, and then it's to the power of 5. Now, I suppose technically you could argue that if you did a big expansion of this, that you could, in that case, just do a big expansion and then just use the power rule, or do some sort of expansion and use like the product rule or something like that. Technically, I guess that would be possible. So I will admit that maybe the word requires is a bit of a strong word here. However, in order to differentiate this with any sort of like effectiveness, efficiency, I guess not so much effectiveness, but efficiency for sure. To do this with any sort of efficiency whatsoever, we would need the chain rule. The next one, we absolutely do 100% need the chain rule for as well, because again, it's a composite function, right? We have e to the power x is our outside function, and then 4x is our inside function, so we do have two separate functions. So if we failed to use the chain rule, we would end up with the wrong answer. And then same here, right? We have ln x as our inside function, or sorry, outside function, and then we have 3x squared as the inside function. So once again, we have that composite function. And then for this one, 2x plus 3 would be our inside function. So actually that should go over here. And then our outside function is x to the power 5, right? So in all of these cases, we have composite functions. And so therefore, I would say all of the above is the best answer, because at least for sure B and C do. And A, honestly, the only actual efficient way to do it would also be chain rule as well. All right, so this one says if y is equal to sine u, where u is a function of x, then dy over dx is equal to which? All right, so first things first, we would need to take the derivative of the outside function. So what's the derivative of sine? That would be cosine. So it's going to have something to do with cosine of u. And then we would have to take the derivative of u, so times u prime, or I mean, they're using a different format here. So this would be times du dx. So derivative of u with respect to x, right? Derivative of what is inside those brackets, right? We have to include that. Otherwise, we're not fully doing the chain rule. And so the final answer here would be this one here, would be letter B. All right, next let's move on to three free response questions related to the chain rule. All right, so this one says to find the derivative of this function using chain rule and to show all of our steps. Okay, so my first step is I'm going to be identifying which functions are which. So let's let f of x actually just be y and say y is equal to 2x cubed minus 7 to the power of 5. And let's also say that we have y is equal to f times g, or sorry, not times g, f of g of x, right? Because f times g would actually be, that would be product rule, that would be totally different. Okay, so then in this case, I'm going to identify my f and g, that my f is x to the power 5, because that's our outside function, and then g is equal to 2x cubed minus 7. So f prime would be what? That would be 5x to the power 4. And then g prime would be 6x, right? So just very basic, using the power rule to find those derivatives there. Now I'm going to apply that to the overall chain rule, which actually I didn't write down. Y prime is f prime of g of x times g prime of x, okay, times the derivative of what's inside there. Okay, so let's do it. Y prime in this case would be 5 times 2x cubed minus 7 to the power of 4, and then times g prime of x, which would be 6x squared. Or here looks like I missed the squared. My apologies. That should not just be 6x squared. So there we go. Then I'm just going to neaten that up just by multiplying 6x squared by 5 and having them both at the beginning. So then we're going to get that the derivative is equal to 30x squared times 2x cubed minus 7 to the power of 4. And you can just leave your answer like this. There's really no need to, expand this or anything like that. Don't waste your time doing that. This is a good answer. As long as you've neatened things up kind of as well as you can, eat pretty easily, that's good enough. All right, so here's another one. It says to differentiate this function, g of x is equal to e to the power of x squared plus 3x, and simplify your answer completely. Okay, so once again, same kind of thing. We're going to be using our chain rule. So I'm going to be putting the coefficient out in front, right, and saying that it's going to be e, because the thing is, the derivative of e to the power x is just e to the power x, but then times, times 1, right, if it was just x, but we have to chain it, right? And so therefore, the answer is going to be e to the power of x squared plus 3x times the derivative of x squared plus 3x. Now, what's the derivative of x squared plus 3x? Well, that would be 2x plus 3. So therefore, the answer is 2x plus 3 times e to the power of x squared plus 3x for that one. All right, and let's try one last one. A spherical balloon is being inflated such that its radius increases 2 centimeters per second. Using the chain rule, find how fast the volume is increasing when r is equal to 5 and show all your work. Okay, so here's the thing about this question, right? Basically, what they would like to know is the rate of change. They want to know what the rate of change overall is. How fast is the volume increasing? And so how do we find the rate of change? Well, derivative is another way to find rate of change, right? That's another word essentially for the rate of change. And so essentially what we're going to do here is we're going to say, well, we know that the derivative of the volume, so rate of change in the volume with respect to time, must be equal to the derivative of the volume function, right? So derivative of the volume function with respect to r times dr dt, right? The rate of change, the change of the radius with respect to the time, okay? So let's find out what both those things are. Well, what is dv over dr? Well, that would be, if we look at this equation here, that would be 4 over 3 times 3 pi r squared, which then we cancel those out. We get 4 pi r squared. So that one's 4 pi r squared. And then dr over dt, they actually told us what that was in the question. They said that the radius increases 2 centimeters per second. So the change in the radius with respect to time in seconds is 2. So my answer is going to be 4 pi r squared times 2, which is 8 pi r squared. And so therefore 8 pi r squared is going to be generally our change in volume with respect to the radius. So here they would like to know how fast is the volume increasing when radius is equal to 5. So now I'm going to sub in 5. So what is dv over dt when the radius is 5? Well, I'm going to plug in 5 here. So I'm going to get 8 pi times 5 squared, which is 8 pi times 25, which is 200 pi. And so therefore, the final answer would be 200 pi, and then units would be cubic centimeters per second. And so there we go. That's going to be our final answer. As always, if you did have any questions, feel free to leave those in the comment section, and we'll see you for the next one.